The problem statement tells us that we have a regular n-gon and a regular n-gon, and the interior angle of the n-gon is 24 more than that of the n-gon, and we pretty much want to find all the values of n. So it's well known that like the angle in an m-gon is going to be m minus 2 times 180 for m, and for an n-gon it's going to be n minus 2 80 over n, and for the problem statement we know that we should have a plus 24 there to make like the angle measure 24 more. And from here we can do some cancellation. This gives us that like 15 and n is 30 n right equals 15m n minus 30m plus 2mn, and then that gives us the mn minus 15m plus 15n is equal to 0. Then from here we can apply Simon's favorite factoring trick, which tells us that mn minus 15m plus 15n minus 225 plus 225 equals 0. Here we get that like m plus 15, I think, and minus 15 is equal to negative 225. And this gives us that m plus 15 minus n equals 225. Obviously, as m plus 15 is positive, as n is like a number of side lengths, then like n is then 15 minus n is going to be greater than or equal to greater than 0, and then 220. Now, so then we can list like the positive factors of 225, and those are going to be like 1, 3, 5, 9, 15, 15, I think 25, there's going to be 45, right, and then there's going to be 75 and 225, and immediately like we see that these are all impossible for values of 15 minus n, because n is greater than 0. So then for all these we see that for 1, n equals 14, n is going to be like 210, that works. And then you also, for 3, you get n equals 12, and this should be m. M is going to be equal to 75 minus 15, which is 60, for n equals 5, and is going to be equal to for n equals 10, m is going to be equal to 45, for n is equal to 6, n is equal to 25. And then we see that all these are valid, and since we solved that equation without like doing any anything weird, then we're not gonna like get extraneous or miss any solutions, so we can just add these up and get that the total sum is equal to 42, which is the answer.